Okay, hello everyone, and welcome back. Today we're going to simplify radical expressions because we're going to solve quadratics by taking square roots next. So we thought we'd kind of review a little bit again, simplifying radical expressions. All right, today's objective, to write equivalent radical expressions. All right, and guys, a radical is the square root sign. That's what we're talking about. We're talking about square roots. All right. Today's essential question, what does it mean to simplify a radical expression? I mean, what does that mean? Okay? And we're looking for perfect squares that are underneath that radical sign. Because then we can take them outside because they're a perfect square. All right? Remember that you square a number. What does that mean? You multiply the number by itself. Okay? This is a chart of all the perfect squares, up to 30 squared. And you need to know these perfect squares because you're looking for perfect squares that are factors of the numbers that you're trying to simplify. All right, a square root symbol, it looks like this. All right, you've seen it before, I'm sure. It's called a radical. All right, and the number that is inside the radical sign or underneath it is called the radicand. As a square root is the number you multiply by itself to get the radicand, to get the number that you're starting with. Okay, and again, this is a chart of perfect squares and the square roots, all right? All right, how do you compare like the square root of 20 and 2 times the square root of 5? All right, there's something called the product property of square roots. Now, it's pretty simple. It means that the square root of AB is equal to the square root of A times the square root of B. All right, as long as neither A nor B are negative, they have to be greater than or equal to 0. All right, because you can't take the square root of a negative number, not in the real number system. Okay, however, we can use this property and take a look at the square root of 20. Well, the square root of 20 is the square root of 4 times the square root of 5. I mean, 4 times 5 is 20. And 4 is a perfect square. All right, 2 times 2 is 4. So when you get the square root of 4 like that, you can just take it outside and say, okay, it's 2. So 2 times the square root of 5. So the radical expression, the square root of 20, simplified, we'd write it as 2 times the square root of 5. But here's some more examples. Again, this one here, we're looking for the square root of 72. Now we're looking for factors of 72 that are perfect squares, right? And you're going to be able to find them in these problems, okay? Because we're practicing doing this. Right, 72 is 36 times 2, and 36 is a perfect square. I mean, the square root of 36 is 6. So we can take the 6 outside the radical sign and leave the 2 inside, because 2 is not a perfect square. We can do the same thing here for the square root of 63. Yeah, the square root of 63. 63 is 9 times 7, and 9 is a perfect square. It's 3 times 3. So you can take the 3 outside the radical sign and just leave the 7 inside. And it's okay if the radical has a coefficient. If there's a 2 in front already, that's okay, just leave it there. Right? 80 is 16 times 5. 16 is a perfect square. All right? The square root of 16 is 4. So we can take the 4 outside. The 2 is still there, so it just becomes 2 times 4. So now the coefficient is 8, okay? Also, guys, we use variables. All right, x squared, x to the 9th. We can put y in there as well. All right, you remove the perfect square factors that are inside the radicand. Again, 63 is 9 times 7. All right, x to the 9th. Well, you can rewrite that as x to the 4th times x to the 4th times x. There's 9 x's right there. And x to the 4th times x to the 4th, I mean, once you get 2 of them, you can take one of them out. Take one of those outside the radical sign. The same thing we're doing with the 3's. The square root of 9 is 3. 3 times 3. So once you get 2 of them underneath the radical sign, you can take one outside. All right, so the 3 and the x to the 4th come outside the radical sign. And what's left? There's a 7 still in there, and there's one x still left. Okay, so the original expression, 63 x to the 9th, the square root of that, is the same as this expression. This is simplified. 3x to the 4th times the square root of 7x. Those are the same, all right? If you notice with the variables, guys, an even number of variables can always be taken outside the radical sign. All right? So when you're simplifying, you should never leave a variable underneath the radical sign with an exponent greater than 1. All right, look at this example. There's x to the 3rd. So there's 3 x's in here. So we can take 2 of them outside. I mean, we can take one of them outside by getting rid of 2, okay? Because it's x squared. All right, that leaves 1x inside. Guys, if there was 2 x's inside, we could take them both out. If there were 3 x's inside, like this one starts, we can take 2 outside and leave 1. Again, if there's 4 x's inside, you take them all out. If there's 5 x's inside, you take out 4 of them and leave 1. All right? So you can always take an even number of variables outside and leave 1 inside. All right, we can multiply the radical expressions together. It's kind of like multiplying like terms. You take the coefficients, in this case the 3 and the 5 and the 2, and put them together. 3 times 2, that's 6. Then take the radicands, the numbers that are inside underneath the radical, and put them together and multiply them together. And then simplify it, which is what we're doing here. Okay, 5 times 15. Right? The prime factorization is 5 times 3 times 5. And there's 2 5s, so we can take one of them out. And here, x to the 4th, there's 2x squared, of course, so we can take 1x squared out and eliminate them underneath the radicand, underneath the square root sign. Okay, so all we're left here in this is the square root of 3 underneath the radical sign. That's all we're left with. Okay? Let's do another example. Guys, again, take 1/2, which is the coefficient, times 4. 1/2 times 4, that's 2. Then take what's inside underneath the radical sign, underneath the square root sign, and multiply all that stuff together. 21 times 7 is 147. All right, here's 3 x's, and there's 2 more here. So 3 plus 2 gives you 5 x's. Remember, when you're multiplying, you're adding the exponents. When you multiply powers, you add the exponents. All right, 147 equals 7 times 7 times 3. That's 49 times 3. So we can take a 7 outside the radical sign. Again, x to the 5th is the same as x squared times x. So we can take x squared outside. And all that's left inside is a 3 and 1x. All right, so 3x is left inside the radical sign. 2 times 7 is 14, and x squared comes out. Let's do another example. I have to hurry up, guys. You can always stop this. Again, the 2 is outside. Take the 12 and the 18 inside and multiply them together. Take the x to the 9th and the x to the 5th. Multiply them together, so now we have x to the 14th. And 12 times 18 is 216. Right? 216 is 6 times 6 times 6. So we can take out 1 6, but we have to leave 1 inside. All right, x to the 7th, because it's x to the 14th, it's x to the 7th times x to the 7th. Take x to the 7th out. All we're left inside is 1 6. That's all that's left inside. All right, so we leave it underneath the radical sign. 2 times 6 is 12, and there's 7 x's outside now. Guys, sometimes we use 2 different variables as well, an x and a y. Don't let it worry you. Just divide it up the same way. In this case, 180 has a perfect square factor of 36. 36 times 5 is 180. So the square root of 36 is 6, so it comes outside. The 5 stays inside. There are 3 x's, so 2 of them can be eliminated by taking 1 outside. And then there's 2y squared, so we can eliminate both of them by taking 1 outside again. All that's left inside is 1x and 1 5. Okay? Guys, this is a nice summary of everything. Again, a radical expression is written in simplest form when there are no perfect square factors underneath the radicand, except for 1. All right, we looked at the property of square roots. And guys, here's some examples. This is if you just use numbers, and this is if you multiply 2 numbers. This is an example using variables, and this is if you're multiplying 2 numbers with variables underneath the radicand, underneath the radical. Okay, next, guys, please fill out the notes assignment and complete the vocabulary. Is now in the green folder. When you're done with that, go straight to the orange folder. There's a discussion assignment that I want you to complete before the next Zoom meeting. And we'll do the summary in the second Zoom meeting. Okay, that's it. Thanks.